The cosmos has a way of keeping us humble. Every time we believe we have mapped its mysteries, it offers a new enigma quietly, without warning, as if whispering across the infinite dark. For centuries, Mars has hung in our night sky like a familiar companion, a silent, red world, cold, barren, and predictable. Yet now, a visitor from beyond 3I Atlas has entered its orbiting story, and suddenly, that predictability is beginning to fracture. Strange signals ripple through the instruments. Odd behaviors echo in the data. Patterns that should be random instead unfold with an unsettling rhythm. Some scientists suggest these are natural fluctuations and gassing, gravitational stresses, the ordinary pulse of cosmic mechanics. But others are not so certain, because the timing is too precise. The alignments are too deliberate, and when viewed from the stillness of the night sky, the coincidences begin to feel less like accidents and more like intentions. Imagine, for a moment, if Mars itself is no longer passive, if something unseen is stirring within its soil, its thin atmosphere, its silent magnetic field. Could it be coincidence that these changes mirror the arrival of 3I Atlas? Or is there a deeper connection, a hidden conversation between a wandering visitor and a waiting planet? We cannot say for sure. Perhaps it is natural, a simple alignment of forces we do not yet understand, but perhaps it is something more. Think about that for a moment. What if Mars itself is being prepared for something? Drifting silently through the solar system, 3I Atlas is more than just another interstellar visitor. It has sparked a quiet storm of speculation in observatories across the world. A storm not shouted in headlines, but whispered in late-night conversations between scientists who know how fragile certainty can be. At first glance, it should be ordinary, a fragment of rock and ice, wandering across unimaginable distances. But the deeper the observations go, the stranger the story becomes. Its energy signatures don't add up. Its rotation seems too precise, and now its path brushes near Mars in ways that defy easy explanation. This is where the title of our journey takes shape. 3I Atlas has sparked a terrifying new theory, one tied not to Earth, but to Mars itself. Some wonder if the object carries with it the seeds of transformation. Could it be altering the Martian environment, preparing the planet for changes we cannot yet imagine? Or is it simply coincidence? Are human minds bending patterns into meaning where none exists? The truth is uncertain, yet the unease is undeniable, because each night that 3I Atlas creeps closer to its encounter, the question grows louder, echoing through the silence of space. What if this is not random? What if Mars is part of a design? What if we're not ready for the answers we seek? The thought lingers as 3I Atlas drifts ever closer, carrying mysteries we can only begin to imagine. But tonight, as we travel together through this unfolding story, I'd love to hear your thoughts. Do you believe this is natural, or could it be something more? If you find comfort in these cosmic explorations, consider joining this journey by liking this video, subscribing for future episodes, and leaving your reflections in the comments. Your voice helps shape the path we take into the unknown. The deeper astronomers look into 3I Atlas, the more the numbers themselves begin to whisper a riddle. Energy. It is the lifeblood of every cosmic traveler, the one quantity that cannot hide. Normally, When a comet approaches a star, its story is simple and predictable. Sunlight strikes frozen surfaces, volatile ices warm, and sublimation begins. Gas and dust burst outward, creating the familiar tail that stretches like a cosmic banner. We can model it. We can predict it. In fact, the physics is so well understood that observatories across the world routinely forecast a comet's brightness months in advance, often within fractions of a magnitude. Yet 3I Atlas refuses to obey this script. The thermal data trickling in from orbital platforms around Mars shows something stranger, something that makes scientists shift uncomfortably in their chairs. At its current distance from the Sun, the object should be faint. The numbers say it should glow at a certain brightness, powered only by the steady hand of solar heating. But instead, its energy output is off the charts, measurably higher than any natural sublimation curve can explain. Instruments track levels that climb too steeply, as if some hidden engine were humming deep within its core. The question, quietly whispered in mission logs, is whether we are looking at the physics of a comet or the mechanics of something far less familiar. Compare this to Mars itself, a planet with no right to be connected to this story. Yet, as 3I Atlas slips closer to its orbit, instruments around Mars detect background fluctuations, subtle disturbances in plasma streams, and magnetic turbulence that don't align with solar activity alone. It's as though the very presence of the object is tugging at Mars, stirring the quiet world in ways we cannot yet explain. Normally, a comet has no such influence. They are too small, too fragile, too inconsequential to stir a planet's magnetosphere or alter its ionosphere. And yet, here we are, looking at readings that suggest otherwise. The simplest answer, the one many cautious voices lean toward, is compositional anomaly. Perhaps 3I Atlas carries exotic ICEs, materials that sublimate earlier and faster than expected. Perhaps its surface layers have a chemistry we have not catalogued, producing bursts of heat and gas in ways that defy our Earth-based assumptions. If that's true, then the explanation is natural, though rare. But even then, something doesn't quite fit. The energy output doesn't just overshoot predictions, it overshoots them consistently, as though locked to a hidden schedule. Peaks and valleys appear with precision, repeating patterns that resemble rhythm more than chaos. This rhythm raises a darker thought. What if the object isn't producing energy randomly at all? What if it's managing energy? Some researchers dare to suggest the patterns resemble thermal regulation, the way an engineered system might bleed off heat in stages to avoid overheating, the way spacecraft vent excess energy into space. In this frame, the object ceases to be an inert traveler and instead becomes a participant, active, deliberate, perhaps even reactive to its environment. If so, what is Mars triggering in this strange visitor? Is the red planet awakening something hidden within it? Imagine for a moment the consequences of that possibility. A dormant machine drifting between stars, cold and silent, until a planetary field, perhaps magnetic, perhaps chemical, perhaps gravitational, triggers a response. Mars has long been considered lifeless, a world stripped of its shield, its atmosphere eroded by the solar wind. But what if that very vulnerability, that openness, made it an ideal key? Could Mars itself be a switch in a much larger system, waiting for an object like 3I Atlas to pass close enough to stir it awake. To be fair, the cautious scientist would argue against such speculation. They remind us that anomalies often dissolve under the weight of better data. Perhaps our instruments are miscalibrated. Perhaps thermal models need adjustment. Perhaps the apparent rhythm is nothing more than coincidence, amplified by limited observation windows. This is the naturalist's position. The cosmos may surprise us, but it rarely deceives us. Yet the dual possibility refuses to fade. Because if the data holds true, if the energy cannot be explained away, then we must consider the alternative, that what we are witnessing is not natural at all. And here lies the true unease. If this is artificial, it implies intent. If it is intent, then it implies a purpose. And if it has a purpose, then Mars is not simply a bystander in the solar system's theater, but a stage prepared for an act we cannot yet comprehend. Think about that for a moment. A barren world, long considered dead, suddenly entwined in the behavior of a wandering object from another star. It almost feels scripted, as if we are watching the first scene of a drama that has been rehearsed for millennia. The cosmos has a way of humbling us, of showing us how little we truly know. 3I Atlas glows where it should fade. It stirs Mars where it should pass silently. Its numbers whisper defiance against the models we thought were certain. Perhaps, in the end, it will prove to be nothing more than ice and rock, playing a trick of timing and chemistry. But perhaps it is something else entirely, and this is only the first anomaly. The red planet has always been quiet compared to Earth. Its thin atmosphere carries no roar of storms like Jupiter, no thunder of oceans like our own blue world. Mars is often called still, silent, and frozen. And yet, in the last 2 decades, our instruments have whispered. NASA's InSight lander, resting on its barren surface, recorded faint tremors, Marsquakes, proof that the planet is not entirely dead. They were rare, irregular, sometimes tied to cooling crust or the slow cracking of ancient rock. Scientists expected them. They fit the quiet rhythm of a cooling planet. But as 3I Atlas drifted closer to Mars, that rhythm broke. The data logs show it clearly, a multiplication of seismic events, sudden and unexpected. Where 1 or 2 tremors might appear in a week, clusters began appearing within hours. Their timing startled researchers. These were not random fractures echoing through old stone. They came in bursts, aligned eerily with the changing distance of 3I Atlas as it moved toward Mars' orbital path. At first, the correlation seemed impossible. How could a comet-like body, drifting in space, ignite a planet's tectonic restlessness? Mars has no plate tectonics in the way Earth does, no molten core driving vast continental drifts. Its quakes should be slow, scattered. Instead, the planet began to tremble like a drum responding to an unseen hand. The natural explanation insists on caution. Mars' crust is under strain. Its surface, riddled with scars from ancient impacts, holds stresses that may crack open unpredictably. Perhaps these quakes were always inevitable, their timing with 3I Atlas nothing more than coincidence. Stress builds, stress releases simple geology. And yet, the records suggest otherwise. The quakes were not only more frequent, they were more synchronized. Bursts of activity matched orbital alignments, as if some external force was tugging at the planet itself. The question grew harder to ignore. Was Mars responding to something, or was something responding through Mars? To consider this possibility is to step into unsettling territory. Gravitational influences are real. Moons pull at planets, stars tug at comets, tides ripple across oceans. But 3I Atlas is far too small to exert tidal power on Mars from such distances. Its gravity is insignificant compared to the Sun's or even Mars' own moons. Yet, the seismic data traces patterns that do not belong to randomness. Some researchers have begun whispering that the object might not be influencing Mars through gravity at all, but through resonance vibrations, electromagnetic pulses, or even controlled emissions designed to awaken something hidden deep beneath the surface. Imagine the possibility for a moment. A dormant system lying under Mars' crust, silent for millions of years, suddenly stirred as 3I Atlas passes. Could the quakes be signals, not accidents? Could they be the planet's way of responding, like an old machine creaking back to life when the switch is flipped? It sounds extraordinary, but the numbers press the question forward. Tremors follow alignments too closely, as though Mars is echoing the path of this interstellar wanderer. There is another way to see it. Perhaps 3I Atlas carries not only anomalous energy, as we saw earlier, but also fields radiation, magnetism, frequencies that our instruments barely detect. Mars, stripped of its global magnetic field, is more vulnerable than Earth. Its crust holds localized magnetic pockets, remnants of what once was a planetary shield. These magnetic scars could respond more easily to disturbances from outside. In this framing, the quakes are not accidents, but echoes of an invisible handshake between object and planet. A conversation written in tremors, and yet the skeptics hold their ground. They warn us against chasing ghosts. Seismic activity is messy. Our instruments are sensitive, and correlation is not causation. Perhaps the quakes are simply random bursts in a restless crust, amplified in our minds because we already suspect 3I Atlas of being unnatural. In science, caution is a shield against imagination running too far. But in mystery, caution becomes a wall, and walls cannot contain curiosity for long. Because if the timing is more than chance, then Mars is not trembling on its own. It is being touched, awakened, provoked. The psychological weight of this is heavy. Mars has always represented possibility, perhaps once a cradle of life, perhaps one day a second home for ours. But what if it is more than a planet? What if it is a stage? These quakes might not be random noise, but signals of preparation, the groaning of a world being shaped for something yet to come. If Mars is responding, then humanity is no longer just an observer of the red planet. We are witnesses to its transformation, and perhaps unwilling participants in a drama that began long before our species learned to look up at the night sky. And here lies the haunting question. If 3I Atlas can stir Mars, what else might it stir? If seismic energy is the first ripple, what waves will follow? Could the planet's crust hide relics, mechanisms, or long-forgotten structures waiting for this moment? Or is this simply nature playing a cruel trick of timing, forcing our fears to see design in randomness? For now, the ground beneath Mars continues to shake, faint but steady, as though answering the silent approach of this interstellar visitor. Whether natural or artificial, chance or purpose, one truth remains. The red planet has not been this restless in ages, and scientists can only watch as tremor after tremor raises the possibility that Mars is not alone in its silence. Something is stirring, something is answering. But quakes weren't the only signs. Mars has always been a planet marked by absence. Where Earth holds a protective cocoon of magnetic force, shielding us from the solar wind, Mars carries only scars of what once was. Billions of years ago, a molten dynamo churned in its core, creating a magnetic field strong enough to preserve oceans and perhaps even life. But the dynamo died, the shield collapsed, and the atmosphere was stripped away. Today, only faint pockets of magnetism remain sealated regions in the crust where iron-rich rocks retain memories of a long-vanished shield. It is a broken echo of planetary protection. And yet, as 3I Atlas drifts nearer, those echoes have begun to whisper again. Instruments in orbit, from the European space agencies, Mars Express to NASA's MAVEN probe, have recorded anomalous subtle fluctuations in magnetic readings that do not fit normal models. These changes are not the sweeping storms triggered by the sun's fury. Solar winds leave clear signatures, bursts tied to the sun's cycles, with magnitudes that spike and fade predictably. But the variations appearing now are quieter, steadier, more deliberate. They pulse with a rhythm that does not belong to solar weather. The natural explanation insists on chance overlap. The sun is active, solar storms ripple outward, and Mars, with no global shield, reacts in strange ways. Perhaps we are simply misinterpreting overlapping influences, layering 3I Atlas onto a picture already painted by solar activity. But as researchers compare the timing of magnetic fluctuations with the trajectory of the interstellar visitor, the alignment becomes hard to dismiss. The pulses often coincide with the object's position relative to Mars, as though some unseen communication is unfolding between rock and planet. Imagine it, an external body reshaping the whispers of a dead magnetic field. Could 3I Atlas be projecting fields of its own, weaving interference into Mars' fragile remnants? If so, the implications are chilling. Magnetic fields are more than invisible shields. They influence atmosphere, radiation exposure, and even how energy interacts with a planet's surface. If something or someone could manipulate a planetary magnetic signature, they could alter its fate. They could prepare it, transform it, or protect it for reasons beyond our understanding. The skeptic's view remains anchored. They argue that instruments are sensitive, prone to overinterpretation. Weak magnetic fields fluctuate often, influenced by crustal variation, solar interference, or measurement noise. To leap from anomalies to external manipulation risks stepping outside science. Yet, as the data grows, a pattern emerges, pulses that seem too organized, too measured, like a distant beacon tapping a message across the void. Not chaotic, but deliberate. There is another dimension to consider. On Earth, magnetic fields guide migration. Birds, whales, even bacteria navigate through the unseen lines of planetary force. If Mars' field is being touched, however faintly, could it influence life for the potential for it on a deeper level? Some theorists whisper that if 3I Atlas is artificial, its manipulation of Mars' magnetism may not be about protection at all, but about reactivation. A planetary reboot. And what of the possibility that Mars is responding, not passively, but actively? Perhaps the ancient dynamo is not fully dead. Perhaps remnants lie dormant, waiting for an external spark. Could 3I Atlas be that spark? Could the magnetic whispers we detect be the first signs of a system waking from slumber, coaxed back into motion by resonance or design? If so, then Mars' story is not finished. It is only beginning again, rewritten by an interstellar hand. The emotional weight of this idea cannot be ignored. Humanity has long dreamed of terraforming Mars, of building shields, reigniting cores, creating an atmosphere where one no longer exists. But what if the process has already begun without us? What if we are not the engineers of Mars' future, but the bystanders, watching, powerless, as an unknown visitor conducts experiments across a world we hoped to call our own? Pause and consider the fragility of this moment. A weak planet whispering through faint magnetic scars, a silent traveler crossing the void. Their interaction defies our expectations. The skeptic insists on caution. The dreamer insists on significance. But beneath both lies an undeniable truth. Mars is whispering louder than it should. Something is touching its broken shield, something we cannot yet explain. And so the question lingers: could an external visitor reshape a planet's shield? The answer hides in the data, in the silence between pulses, in the whispers of a planet that may not be as quiet as we once believed. But the magnetic anomalies were not alone. As researchers dug deeper, they uncovered another mystery, one not in the invisible field above, but in the very surface itself. Something buried, something ancient, now stirring in ways that cannot be ignored. And here, the mystery only deepens. Mars has always carried a thin and fragile breath. Its atmosphere, barely 1% the thickness of Earth's, is composed mostly of carbon dioxide, laced with faint traces of nitrogen, argon, and the occasional whisper of water vapor. For centuries, this thin veil has told the story of a world that once might have been alive with rivers and oceans, but is now stripped, barren, and cold. Scientists have studied it in great detail, from the Viking landers of the 1970s to today's rovers and orbiters. The chemistry is supposed to be simple, predictable, stable, and understood. But as 3I Atlas drifts nearer, something in that thin Martian breath has changed. Instruments aboard orbiters have begun detecting unusual isotopic ratios, arrangements of atoms that do not match the expectations of natural chemistry. Oxygen appears in combinations that should not be stable at current temperatures. Traces of noble gases suggest processes. Even the carbon dioxide, which has always been the backbone of Martian air, carries subtle signatures of imbalance, as if it has been altered or fine-tuned by invisible hands. In the natural view, scientists argue that these oddities could be explained by surface interactions. Sunlight breaks down molecules in unpredictable ways. Dust storms loft particles into the air, catalyzing chemical reactions we do not yet fully understand. The Martian soil itself is reactive, rich in perchlorates and compounds that, when disturbed, can create surprising chemical byproducts. The anomalies, they say, are not messages, they are byproducts of a complex, poorly understood system. But others cannot ignore the pattern. The isotopic signatures appear too selective, too consistent, as if part of a recipe. Ratios line up in ways that echo industrial refinement, where elements are concentrated not by chance but by design. When compared to natural models, the deviations do not scatter randomly. They cluster tightly, as though guided by intent. It is here that whispers of an engineered cocktail begin to stir. What would it mean if Mars is breathing differently? Imagine an atmosphere not merely weathered by natural forces, but prepared to suit particular needs. A shift in isotopes could suggest terraforming, a gradual reshaping of chemistry to support life, or at least to create conditions that favor stability. Some speculate this could be a precursor to habitability, the laying down of invisible foundations for future growth. Others see a more ominous possibility, a planetary experiment conducted for reasons we cannot fathom. Think about this quietly for a moment. On Earth, the balance of our atmosphere sustains us with exquisite precision. Oxygen levels rise and fall with the growth of forests and the activity of oceans. Carbon dioxide fluctuates with seasons and industry. It is not just air, it is the living fingerprint of a biosphere. If Mars now shows signs of an engineered fingerprint, then the planet may no longer be a passive rock in the sky. It may be in transition. And what of the connection to 3I Atlas? Could the arrival of this visitor be coincidental, or is there something more? Some theorists argue that as the object approaches, it could be releasing particles, gases, or fields that interact with Mars' fragile air. Others suggest a deeper link, that the object carries knowledge, technology, or even mechanisms designed to awaken Mars slowly, transforming its chemistry in preparation for something unseen. Could we be witnessing not a random anomaly, but the first signs of planetary modification? Skeptics push back, of course. They remind us that extraordinary claims demand extraordinary evidence. Isotopic anomalies can come from meteor impacts, solar interactions, or even errors in measurement. Instruments in space are delicate, prone to interference. To leap to conclusions about engineering is to risk stepping outside science. And yet, the anomalies persist, measured by different instruments, across different missions, confirmed again and again. The question becomes not whether Mars is breathing differently, but why. Is this a planet struggling to maintain equilibrium in the face of external pressure? Or is it the quiet exhalation of a process we have not yet recognized? Perhaps natural, perhaps something in between. The poetic weight of this cannot be ignored. Mars, the silent world, suddenly exhales in new ways. Its thin breath, once stable and predictable, now carries hints of mystery. It is as if the planet itself is whispering, its atmosphere changed, its chemistry bending toward a destiny we cannot yet read. And this leads us to a chilling thought. If Mars is breathing differently now, who or what is it breathing for? Could it be for us, preparing to welcome humanity with conditions just slightly less hostile? Or could it be for something else entirely, a presence waiting in the wings, unseen yet shaping the air of a world long abandoned? The atmosphere is not just air. It is a message, written in invisible ink, across the skies of Mars. The message is incomplete, half-hidden, waiting for the right key to decode it. But as 3I Atlas looms closer, the changes in the Martian breath become harder to dismiss. And perhaps, when we finally read the message clearly, it will tell us that Mars is no longer the dead planet we thought it was, but isotopes and invisible whispers were only part of the puzzle. For beneath the thin veil of air, the very dust of Mars itself began to tell another story of signals, particles, and lights that seemed to pulse in ways nature alone might struggle to explain. And here, the mystery deepens yet again. In the vastness of space, most small objects tumble. They drift like forgotten fragments, their shapes uneven, their motions chaotic. A comet knocked by countless collisions, an asteroid scarred by ancient impacts. These bodies roll and spin in unpredictable ways. Their dance is clumsy, determined by the random violence of the cosmos. Astronomers have come to expect this. Chaos is the rule. Disorder is the language of nature, and yet 3I Atlas breaks that rule. From the first glimpses through telescopes, observers noticed something uncanny. Its spin is not chaotic. It does not tumble like a shard of stone cast adrift. Instead, it rotates with a steadiness that borders on mechanical. Every observation, across nights and weeks, has shown the same rhythm, wavering, precise, and silent. A cosmic pendulum ticking with flawless timing. To scientists, this is deeply unsettling. Natural bodies acquire irregular spin states through their long journeys. Outgassing from a comet's surface pushes them off balance. Gravitational tides nudge their axes. Over time, the randomness compounds, creating irregular light curves that flicker as the object spins. But 3I Atlas shows none of this. Its brightness variations repeat with clockwork fidelity, as if rehearsed, as if guided. There are natural explanations to consider. Perhaps the object's shape is unusually uniform, its mass distributed with rare perfection. In such a case, its rotation might stabilize, resisting the disturbances that usually haunt smaller bodies. Or maybe, by chance, its surface vents release material so evenly that no torque builds to disrupt its spin. These are possibilities, grounded in physics, however improbable. But another possibility lingers in the silence. What if such precision is not accidental? What if it serves a purpose? A steady rotation would allow an object to maintain orientation, aligning instruments or sensors with distant targets. It would allow surfaces to regulate temperature, balancing exposure to starlight with the chill of the void. In other words, it could be intentional. Think of the contrast. A natural fragment spins like a coin flipped on rough ground, wobbling until it falls. An engineered craft spins like a gyroscope, steady, disciplined, designed to resist disturbance. 3I Atlas leans toward the latter. And though we cannot yet prove it, the suspicion grows with each night of flawless measurement. This is where the mystery touches something almost human. For centuries, we have built devices to keep time: pendulums, clocks, satellites, stabilized by gyroscopes. Each tick, each rotation, a declaration of order against the chaos of the universe. To see such order on an object drifting from the stars is to feel the echo of intent, as if someone, somewhere, demanded discipline where nature prefers disorder. And if this is so, what might be the purpose? A stable orientation could be used to transmit signals, keeping antennas aligned across vast distances. It could power instruments needing steady direction or maintain sensors aimed at specific planets. Perhaps Mars, perhaps Earth. Its silence in radio frequencies does not rule this out. Technology advanced enough to cross interstellar space might operate in ways we do not yet recognize. Perhaps the message is not in signals but in presence itself, in the simple demonstration of impossible precision. But let us not leap too quickly. Skeptics urge restraint. They argue that without more data, we are filling silence with imagination. The object spins steadily, yes, but rare does not mean artificial. The universe is vast. Given enough bodies, some will appear to defy the odds. Perhaps 3I Atlas is one of those rare coincidences, a natural body so well balanced it mimics design. Still, the unease persists. For the question is not only how it spins, but why now? Why does such an improbable visitor appear on this trajectory at this moment in our history? If coincidence, it is extraordinary. If not coincidence, it is something more. And either way, the quiet rotation becomes a symbol of precision in a cosmos that usually prefers disorder. Reflect on this for a moment. Out there, beyond Mars, a traveler turns perfectly steady, hour after hour, day after day. No stumbles, no irregularities, just silence, precision, and rhythm. It is a heartbeat in the void, one that does not falter. Think about the comfort of a ticking clock in a quiet room, and then imagine that same comfort echoing across millions of miles. Now ask, is this comfort natural or manufactured? The duality is inescapable. Nature can surprise us. It can sculpt symmetry out of chaos. But precision carries weight. Precision suggests control, and control implies agency. If 3I Atlas spins like this for a reason, then it may not be merely drifting through our system. It may be watching, measuring, waiting. Its silence could be the pause before an action we cannot yet predict. And so, the question lingers in the night. Could a fragment of stone hold such perfect order on its own, or are we glimpsing the signature of hands, unseen but deliberate? Whatever the truth, the silent rotations of 3I Atlas are not the end of the mystery. For beyond its steady spin, researchers began to notice another puzzle, not in the motion of the body itself, but in the light it reflects. Flickers and hues, faint but undeniable, shimmering as though signals are written into the very glow dot. And here, the mystery deepens further still. The night sky has always been a calendar for those who watch it closely. Long before telescopes and spectrographs, people mapped the stars to track seasons, to plant crops, to mark ritual time. Among the oldest of these sky maps are the star charts etched by Mesopotamian astronomers, careful, patient records that tie celestial motion to human rhythms. They charted planets, tracked lunar cycles, and noted the slow dance of the heavens across generations. We think of those charts as artifacts of early science, but now, plotted against ancient Sumerian tables, a pattern emerges. The windows of closest approach, the narrow intervals when a distant object would appear most prominent. From the inner planets line up with dates that the old charts highlighted as significant. These aren't random marks. They are repeated entries, observed over decades and centuries by sky watchers who left their notes etched in clay. The match is not perfect in the way modern ephemerides are, but the coincidence is too tight to dismiss casually. It raises a subtle question that moves from curiosity into unease. On one hand, we must respect probability. The sky is vast and cyclical. Over thousands of years, many alignments will repeat and reappear. Stars, precesses, orbits perturb, and human calendars shift. It is the nature of periodic systems to intersect occasionally. A few matched timings might be nothing more than the slow arithmetic of celestial mechanics and human attention. Statisticians caution us to expect outliers. Given enough data, patterns will appear that toy with our craving for meaning. The skeptics remind us that pattern recognition is a human survival trait. When unchecked, can turn coincidence into conspiracy. On the other hand, the precision of the match is striking in ways that simple chance struggles to explain. The Sumerian tables were not pop science doodles. They were the work of patient observers who recorded subtle motions across generations. To align a modern interstellar visitor's perihelion with entries in those very tables suggests timing that spans millennia. That, in turn, suggests foresight. Who or what could plan such timing? Could a displacement of trajectory be orchestrated long ago? Or might a system of automated instruments have been programmed to wait for a particular cycle before making itself known? This leads us into the realm of mechanisms and agency. One plausible natural story holds that the clustering of dates is an artifact. Humans fix a date on luminous apparitions and retroactively ascribe importance to the moments they deem dramatic. Another natural story places the responsibility with the dynamics of the galaxy. Streams of debris shepherded by stellar encounters might arrive in correlated bursts, their orbital phasing governed by gravitational tides of distant times. But these explanations, while rooted in physics, require chains of contingent events that grow improbably long when pushed to match the observed alignment with antiquity. If we step beyond purely natural processes, a different narrative begins to appear. It does not have to be deliberately malevolent or benevolent. Intention could be mechanical, algorithmic, or archival. Consider the possibility of a probe or a fleet of instruments designed to activate or reveal themselves when a target civilization reaches a particular stage, or when a specific planetary geometry recurs. To achieve that would require a conception of time that spans generations, even epochs. It would require autonomy and durability beyond anything human technology has yet demonstrated. And yet the match with ancient calendars hints at systems that might operate on such scales: slow machines, patient and precise. The historical perspective deepens the mystery. Sumerian astronomy was careful about cyclical recurrence. Their calendars encoded not just solar years, but subtler relationships, synodic cycles, conjunctions, and repeating patterns of visible planets. For an interstellar visitor to intersect those same cycles at moments noted by those ancient observers, the choreography must either be a grand coincidence or a very old plan. The thought causes a curious reversal of time. Instead of us searching the sky for newcomers, we imagine artifacts that were placed where they would be noticed by a future species, that future species being us. Yet, the idea of a long game does not necessarily imply sentient planning of a kind we immediately recognize. It may imply engineering of a different sort, tangent constructs designed to respond to specific orbital mechanics without requiring ongoing control. Imagine devices or fragments launched into trajectories that, after centuries, would intersect inner systems at predictable phases. Such creations could be time-delayed beacons or tools meant to deliver material, information, or catalytic processes when certain celestial clocks ticked. In that scenario, the Sumerian charts were not prophetic. They were simply recording the moment these mechanisms became visible. We must also consider human agency in making the connection. Our interpretation of ancient records is filtered through translation, context, and modern expectation. Clay tablets can be ambiguous. The way we map their notations to modern calendars is subject to calibration. Small errors in date conversion or in assumptions about the ancient observational baseline can exaggerate the apparent fit. Responsible scholars, therefore, test these alignments under multiple models, checking for robustness against dating uncertainties and precessional corrections. Where the match holds under varied assumptions, the pattern becomes more compelling. Where it falls apart, the pattern dissolves. Even with careful scholarship, the emotional resonance of the idea remains powerful. Humans long for connection across time. The notion that our distant ancestors observed the same cycles that now coincide with a visitor from the stars creates a narrative bridge between clay tablets and radio telescopes. It stirs the imagination in ways that pure orbital mechanics rarely do. This is why the talk of ancient watchers circulates among commentators. The phrase captures a sense of continuity, of a cosmos that has been keeping appointments long before modernity. But we must avoid slipping into myth. The evidence must be weighed in light of all alternative explanations. Perhaps streams of interstellar debris do tend to produce clustered arrivals. Perhaps our detection biases amplify patterns. Perhaps the match is a statistical fluke. The scientific method demands rigor, replication, and an unwillingness to accept pleasing stories in place of robust proof. Yet the allure of the possibility that an arrival might have been timed to intersect human history refuses to fade. As the analysis continues, telescopes and historians work in parallel. Orbital modelers refine trajectories with ever more precise astrometry. Philologists revisit cuneiform texts, cross-checking calendar conversions and contextual notes. Each new data point can strengthen or sever the tenuous link connecting clay and comet. For now, the match remains an unsettling invitation to think bigger about time, intention, and how civilizations, ancient or otherwise, might leave traces across the ages. And so we return to the question posed softly at the beginning. Was this date simply a coincidence in an indifferent sky? Or was it set into motion long before humanity was prepared to notice? The implication is as chilling as it is beautiful. The cosmos may keep schedules that outlast empires and languages. And on one of those schedules we find ourselves marked. Was this timing chosen long before humanity was ready? In the search for intelligent signals, silence is rarely neutral. Radio telescopes around the world have been trained on 3I Atlas, their dishes sweeping across frequencies from the familiar bands of human communication to the deep spectra, where natural phenomena sometimes hum. Night after night, they wait for the unmistakable sign, a narrow, structured frequency, the telltale fingerprint of a transmitter. But the instruments hear nothing, only the background noise of the galaxy and the hiss of solar interference. No pings, no beacons, no coherent signals. At first, this seems perfectly natural. After all, comets and asteroids are mute. They reflect sunlight, they scatter dust, they shed gases. They do not speak in radio. Their silence is expected, even comforting. For most scientists, the lack of radio emissions supports the hypothesis that 3I Atlas is just another interstellar fragment, however unusual its behavior may appear. If it were truly a craft, surely we would have heard something by now. But the contradiction gnaws at the edges of that comfort. For this is no ordinary fragment. Its energy profile defies simple models. Its rotational stability echoes precision, and its timing unsettles probability. In light of such strangeness, the silence becomes harder to dismiss. If there is intelligence at play, why does it remain so quiet? Why send anomalies but no voice? One explanation considers technology far beyond our reach. Human civilizations, in their infancy of radio, broadcast loudly, spilling signals into space. But with time, transmissions grow quieter, narrower, more efficient. Fiber replaces radio. Lasers outpace dish arrays. Communication evolves into forms that primitive ears cannot detect. If 3I Atlas is artificial, it may not broadcast in any way we recognize. Its silence, then, would not be absence, but sophistication, a deliberate invisibility, born of design. Another possibility is stealth. An advanced craft entering a system might choose to mask its emissions, hiding from detection while still conducting its purpose. The absence of signal could be intentional camouflage, a cloak to ensure it passes unnoticed by civilizations just learning to listen. From this perspective, the silence is not neutral but active, the product of technology designed to avoid contact until a particular moment arrives. Skeptics remind us of a simpler view. Space is full of quiet objects. Most bodies, even energetic ones, do not produce narrowband emissions. Their energies manifest as heat, light, particles, but not structured signals. To interpret silence as stealth risks anthropomorphizing, projecting human motives where none exist. The data fits perfectly with the natural hypothesis. A comet, however odd, is still a comet. Its silence is not suspicious, is expected, yet the duality cannot be escaped. Natural silence is one thing, but silence that accompanies behaviors inconsistent with nature is another. The contrast is what unsettles. Anomalous energy outputs without electromagnetic chatter. It is as if a fire were burning without smoke, or a machine were operating without noise. The dissonance raises suspicion. This is where philosophy enters. What do we expect from intelligence? Do we expect it to announce itself, to declare presence across the void? Or do we expect subtlety, hidden operations, observation without interaction? The silence of 3I Atlas forces us to reconsider our assumptions. Perhaps intelligence, if it exists, is less about communication and more about control of energy, control of visibility, control of discovery itself. And think of the weight this places on observers here on Earth. Every hour spent listening reinforces the absence. Each negative result deepens the paradox. The great radio observatory Zarusibo, once Green Bank, now Meerkat in South Africa stand, as ears cupped to the cosmos, waiting for a signal that refuses to arrive. Each null detection is recorded, catalogued, analyzed, and still 3I Atlas glides on, silent as a shadow across the solar system. Is it truly silence, though, or are we failing to hear? It is possible that the signals exist, but lie outside our instruments, re-encoded in exotic frequencies, embedded in particle beams, or folded into dimensions we cannot measure. Two beings capable of engineering trajectories across light years. Communication might not resemble our primitive broadcasts at all. What seems like quiet to us may, to them, be a roaring dialogue we lack the senses to detect. The silence, thus, becomes a mirror, reflecting our limitations as much as the object's nature. We strain to interpret what we cannot perceive. We weigh anomalies against the absence of sound. And in that weighing, we are forced into a state of suspense. For silence is not proof, it is uncertainty. The dual framing persists. On one side, silence is evidence of natural origin, rock and ice, unthinking, unfeeling, carried along by gravity and chance. On the other, silence is deliberate concealment, intentional choice by something that prefers observation over contact. Both interpretations hold, both explain the data, and until more evidence emerges, we are left balanced between them, staring at a quiet traveler whose very muteness speaks volumes. So we arrive at the chilling question: is 3I Atlas truly mute, or is it whispering in ways we cannot hear? And just as this question takes hold, another anomaly rises to the surface, not in silence, but in sight. 4 telescopes began to record strange flashes and reflections, light that seemed to dance unnaturally along its surface, as though a code were being written in brightness itself. And here the mystery deepens once again. In space, dust is ordinary. Comets shed it, asteroids scatter it, and cosmic winds carry it across light years. These tiny fragments, born from collisions and heat, become the raw material of nebulae and the seeds of planets. To study dust is to study the universe in miniature, each grain a story written in stone and ice. But the dust released by 3I Atlas is not ordinary. In fact, it is unlike anything we have ever collected from a natural object drifting through the solar system. When high-resolution spectrometers analyzed the particles streaming behind the interstellar visitor, the results startled researchers. Instead of the expected irregular bits of carbon and ice, the grains showed crystalline structures, geometric, uniform, repeating. Their optical behavior suggested lattice arrangements that seemed too precise to be sculpted by chance. Light scattered in patterns that resembled engineered glass or refined metals rather than chaotic cosmic debris. For many, this was the first moment the object's mystery slipped from the abstract into the tangible. Naturally, scientists sought conventional explanations. Could unusual conditions in deep space have allowed slow crystallization? Might long-term exposure to cosmic rays create order from chaos? Laboratory experiments with ESAs under extreme pressures were compared against the signatures, and while some similarities emerged, the match was never complete. Each simulation fell short of the patterns observed. The symmetry of these fragments resisted easy categorization. The idea of engineered material soon crept into discussion. whispered at conferences and debated in quiet papers that rarely reached the mainstream. If a comet fragment can behave like a workshop product, what does that imply about its origins? Could it mean that 3I Atlas carries remnants of processes not geological but technological? Materials formed not by accident but by design. Skeptics offered restraint. Crystalline dust, they argued, may not be impossible in natural contexts. Certain silicate grains, heated and cooled under unique stellar conditions, can develop uniformity. The universe is vast, and rare processes can occur. Just because we have not catalogued them does not mean they cannot exist. From this angle, the anomaly is a challenge to extend our models, not to rewrite them with extraordinary claims. And yet the question lingers: why would interstellar dust, battered by eons of radiation and violent temperatures, arrive so pristine? Crystals, once formed, are fragile. They fracture, distort, blur into irregularity. For them to survive intact across light years, carried on a body now orbiting our star, stretches probability. It suggests either remarkable resilience or recent manufacture. Some observers noted that the crystalline grains did more than survive. Their reflective qualities seemed tuned, scattering light in narrow bands instead of diffuse glimmers. Telescopes recorded spectral lines sharper than expected, as though the fragments were designed to redirect energy in specific ways. To some, they looked less like random dust and more like signal fragments, whispers carried on particles too small to notice unless you knew to look. This is where the narrative bends toward philosophy. If natural, the dust teaches us that matter in the cosmos can organize itself with beauty and symmetry far beyond what we imagined. If artificial, the dust becomes a Cluan artifact of construction, a breadcrumb from intelligence that has crossed the void. Both interpretations are humbling. One expands our understanding of nature's possibilities. The other confronts us with the presence of someone else's work drifting silently through our skies. The debate remains unresolved. Instruments continue to capture and catalog the fragments, while laboratories attempt to replicate them under controlled conditions. Each failure to reproduce their structure naturally nudges the mystery deeper. Each cautious success keeps hope alive for a natural explanation. But the balance between possibility and intent grows thinner with every observation. Dust is supposed to be the simplest thing in the universe, the smallest remnant, the most forgettable debris. Yet in this case, dust becomes the loudest voice. Crystalline fragments drifting from 3I Atlas behave like whispers of technologisoff, fragile and undeniable. What could these whispers be saying? And why now, as Mars draws into alignment with this interstellar stranger? Because just beyond the dust, another anomaly emerges, one written not in particles, but in motion. For weeks, astronomers tracked 3I Atlas across the night sky, projecting its path with models refined by centuries of celestial mechanics. Each calculation followed the same rules: gravity, momentum, radiation pressure. These are the laws that govern comets, asteroids, and planets alike: predictable, testable, reliable. And yet, the more closely the numbers were studied, the more disquieting the picture became. Instead of drifting through the solar system with careless indifference, 3I Atlas seemed to be narrowing its course toward Mars. At first, it was a subtle shift, a minor deviation that could be explained as measurement error. But as the weeks passed, the alignment grew sharper. Its trajectory appeared to bend not wildly, not with the chaos of a random deflection, but with quiet, deliberate precision. If natural, the explanation should lie in gravitational assists and subtle forces. Perhaps an unseen fragment altered its momentum. Perhaps outgassing on its surface provided gentle nudges in one direction or another. These are common occurrences among wandering bodies, especially when they approach the warmth of the sun. But each time analysts folded those factors into their simulations, the same unsettling pattern emerged. The alignment toward Mars remained, as though the planet itself were a destination. This raised an unsettling question, whispered across observatories and research forums. Is this rendezvous intentional? Could an interstellar object, born of chance, fall into such a path with accuracy that rivals spacecraft navigation? Or are we witnessing the shadow of a mechanism at work, an unseen hand guiding it with precision we cannot explain? To the cautious mind, the answer is simple. Probability allows for coincidence. Outgassing jets, even faint, can function like thrusters. Over millions of kilometers, tiny releases of gas accumulate into measurable course corrections. Nature can imitate intention. This interpretation soothes the nerves of those unwilling to face extraordinary implications. Yet, others linger on the improbabilities. The synchronization of trajectory and timing is too exact. Mars, with its fragile atmosphere and buried reserves of water ice, is a planet of possibility, scientifically fascinating, strategically valuable, and hauntingly similar to Earth. If an intelligence sought to observe or prepare a world in our solar system, Mars would be a logical choice. Its thin veil of air makes it accessible. Its history of rivers and valleys makes it enticing. And its current role in human exploration makes it symbolically powerful. Consider the precision required for such a meeting. Across interstellar distances, even a fraction of a degree can scatter a path by millions of kilometers. To align with Mars not just broadly, but closely enough to draw concern suggests calculations far beyond what random drift should allow. It is the difference between rolling a stone down a hill and threading a needle across oceans. Scientists, trained to tread carefully, couch their words in restraint. They speak of anomalous but explainable behavior, of unresolved modeling discrepancies. But outside of formal papers, in hushed exchanges after late nights at the telescope, the tone shifts. What if it was always meant to come here? Someone asks, and silence follows, because no one is eager to answer. The audience for such mysteries is divided. To the science curious, this is a puzzle begging for data. To the dreamers and the mystery seekers, it is evidence of something larger at play. And to those listening at night, seeking calm, it is simply another reminder of how small we are under the weight of the cosmos. But regardless of interpretation, the fact remains. 3I Atlas is not wandering aimlessly. It is bending closer to Mars than our equations predicted, and that closeness carries weight. If it is natural, then it teaches us the limits of our understanding. If it is intentional, then it may mark the first step in a story far greater than ourselves. The trajectory is not the only thing that points toward design, because, as Mars draws near, strange reflections are beginning to echo from its surface. as though the planet itself is answering back. For centuries, Mars has held a strange place in human imagination. To scientists, it is a neighbor of frozen desert, rust-colored and windswept, dotted with canyons deeper than Earth's own oceans and volcanoes taller than Everest. To dreamers, it is a second chance, a frontier waiting for human footprints and domed cities under alien skies. And to storytellers, it has always been a canvas for speculation about visitors, guardians, or civilizations long gone. But tonight, a quieter question emerges from the trajectory of 3I Atlas. What if Mars is more than a world? What if it is a laboratory? Some researchers whisper of a scenario that drifts dangerously close to science fiction, yet lingers on the edge of plausibility. They call it terraforming shadows, the idea that 3I Atlas is not simply passing by, but carrying the seeds of transformation. In the natural world, we already know of panspermia, the theory that life can spread between planets through drifting rocks and icy fragments. Meteorites from Mars have been found on Earth, suggesting that worlds do exchange material across vast distances. Some even speculate that life itself may have been seeded here, carried on comets and asteroids billions of years ago. But panspermia is random, indifferent, and slow. It is a cosmic lottery, scattering spores of possibility across the void, with no intention, no direction, no design. Terraforming shadows, however, suggest the opposite: purpose. If 3I Atlas is more than ice and dust, if it is a probe of some kind, then its cargo may be chosen, its trajectory deliberate, its mission concealed within the guise of natural behavior. Imagine, for a moment, a body entering the solar system, aligning with Mars, and releasing materials into its thin atmosphere. Not chaotic fragments, but carefully tailored compounds, molecules, designed to coax chemistry into new forms. Over time, such seeding could alter the balance of gases, enrich the soil, or introduce microbial catalysts hidden within crystalline structures. The changes might unfold quietly across years or centuries, until one day, Mars is no longer barren but breathing. Skeptics, of course, are quick to point towards simpler answers. Energy signatures and trajectories can be explained by physics. Isotopes can emerge through exotic but natural processes. Marsquakes can echo through its fractured crust without outside interference. In this view, 3I Atlas remains only what it appears to be: a cometary visitor, frozen and ancient, following its own lonely path. Any resemblance to intention is a trick of probability and human imagination, and yet the theory persists, because the anomalies stack in unsettling patterns: crystalline dust that does not fit natural models, timing that matches ancient records, rotational precision that seems engineered. Each thread alone may fray under scrutiny, but woven together, they form a tapestry that whispers of something greater. Consider the poetry of it. A wandering fragment crossing interstellar space, carrying within it the seeds of renewal. To human eyes, it is ice and rock. To Mars, it may be an archive of chemistry waiting to unfold. Terraforming shadows need not be dramatic or immediate. They may be quiet, gradual, and patient, operating on timescales far longer than human lifespans. A laboratory does not reveal its results overnight, and here lies the haunting question. If Mars is being prepared, then for whom? For us, stumbling toward it with rockets and rovers, hoping to carve a new home on its surface, or for something else, something older, that has been shaping worlds long before we learned to look up at the stars. The cosmos rarely offers answers, only mysteries wrapped in patterns. Perhaps panspermia is all we are seeing, life's random scattering across the void. Or perhaps, hidden within the shadow of 3I Atlas, lies a different possibility, that Mars is not simply waiting for us, but has already been chosen for transformation. And if that is true, then the next anomaly reveals even deeper shadows waiting to be uncovered. When we speak of Mars, we often describe it as barren, silent, and lifeless. A desert world suspended in orbit, rusted and quiet, its once flowing rivers reduced to scars across a frozen surface. Yet beneath that silence lies a question that refuses to fade. What if Mars is not merely abandoned, but observed? What if it has always been more than a planet? It has been a test site. This scenario builds on the unsettling anomalies we've already encountered. The energy signatures, the isotopic oddities, the crystalline dustall. These threads weave into a narrative that feels less accidental and more experimental. Some scientists compare Mars to a controlled environment, a laboratory where variables can be tested without the interference of a thriving biosphere. On Earth, life complicates every equation. Ecosystems react unpredictably, feedback loops spiral into complexity. But on Mars, stripped of oceans and forests, the stage is clean, the canvas almost blank. Here, the experiment hypothesis emerges. What if an external intelligence chose Mars precisely because of its emptiness? It offers the perfect conditions, a stable orbit within the habitable zone, a history of liquid water, and no competing civilization to interfere. If you wanted to test planetary engineering, where better than a neighbor world that no one claims, a world visible but untouchable to its closest observers? When researchers examine the synchronized anomalies of 3I Atlas with Mars, some argue that the evidence resembles trial and error rather than coincidence. The dust patterns appear too organized, as though distributed for monitoring. The seismic disturbances align too closely with the comet's approach, like stress tests triggered deliberately. The magnetic fluctuations seem like calibration pulses, measuring how a weak shield might respond to external manipulation. Taken separately, these could all be natural, but together they sketch a portrait of systematic interference. In this framing, Mars is not dead. It is active, not biologically, but experimentally. Its silence becomes less like an absence and more like the quiet hum of a controlled system. And if that is true, then Earth's story grows far more complicated. For centuries, humans have looked at Mars as a potential second home. But in this scenario, Mars is not a future, it is a rehearsal. Its thin air, its fractured crust, its ancient seas all provide the perfect laboratory for testing processes that may one day be applied elsewhere. Terraforming gases, seismic manipulation, atmospheric engineering experiment could be preparing blueprints. And what happens if the next application of those blueprints is not Mars at all, but Earth? The suggestion is chilling. If 3I Atlas is involved in experiments, it may not be random that its trajectory favors Mars first. Earth is too visible, too full of noise and interference. But Mars, isolated and silent, offers a safer stage. To shape Mars is to practice. To practice is to prepare. And what if what is being prepared extends beyond one red desert world? Of course, there is another perspective. Skeptics remind us that science demands restraint. Quakes, isotopes, and orbital drifts can be explained by geology, chemistry, and gravity. The human mind is prone to patterns, eager to impose intention where none exists. To imagine Mars as a test site is to project our own experimental impulses onto the universe. Perhaps we are simply witnessing the random dance of physics, not a hidden trial conducted by unseen hands. But curiosity resists silence. If Earth and Mars have shared materials through meteors, if comets have seeded oceans with organic molecules, then life itself may already be part of an interplanetary experiment. Perhaps the laboratory has always existed, and we are only now realizing that we are both participants and observers. The reflective thought is difficult to shake. If Mars is a controlled experiment, then Earth may be next. Maybe not tomorrow or in our lifetime, but eventually. What if the isotopic signatures detected in Mars' atmosphere are precursors of techniques that could be mirrored in ours? What if the seismic pulses measured beneath its crust foreshadow interventions waiting to be tested here? Think about the psychology of it. Humanity is just learning to engineer its climate, alter genomes, and manipulate energy at scales our ancestors could never imagine. And already we treat Earth as a laboratory, tweaking atmospheric gases, experimenting with fusion, drilling into fault lines. If we, with our brief history, are compelled to experiment on our home, why would we believe that others older, perhaps infinitely more advanced, would resist the same impulse? This scenario, unsettling though it may be, doesn't claim Mars is destined to bloom into green landscapes or oceans. Instead, it suggests that Mars itself may never be the destination. It is the experiment, the intermediate step, the controlled trial whose data will be applied elsewhere. And Earth, with its fragile balance of oceans and atmosphere, may be the next subject in line. That thought lingers as softly as it is disturbing. Mars, long a symbol of exploration, might instead be a warning, a message written not in words, but in anomalies, strange quakes, magnetic whispers, isotopic breaths. And if those anomalies are deliberate, then the experiment has already begun. The question is not whether we are ready to colonize Mars, but whether Mars has already been colonized, not by settlers, but by experiments. And if so, then the silence of the red planet is not empty. It is watchful, and that silence draws us to the next anomaly, one buried deep beneath the surface, waiting to be uncovered. The universe is vast, and within that immensity, silence rules. For decades, astronomers have asked a question that feels both simple and terrifying. If intelligent life is out there, why haven't we heard from it? One chilling answer emerges from what is known as the dark forest theory, a framework that paints the cosmos not as a peaceful expanse, but as a wilderness of fear. In this theory, every civilization is a hunter moving through a dark forest, armed but silent, knowing that any sound could reveal its position. Because in the unknown darkness, another hunter may be listening, waiting, ready to strike. Communication under such logic becomes a fatal mistake. Broadcasting signals is like lighting a torch in hostile woods. You don't know who is watching or what they might do if they discover you. Now, consider 3I Atlas under this lens. Its energy anomalies, its impossible precision, its eerie silence across radio bands. If it were natural, its behavior is extraordinary enough to defy known cometary science. But if it were artificial, the dark forest offers an unsettling explanation. It could be a probe, designed not to communicate, but to watch, or worse, imagine it as a scout, launched by a civilization that believes survival depends on detection before disclosure. Its silence would be intentional, its precision deliberate, its trajectory toward Mars calculated. If the dark forest holds true, 3I Atlas would not need to transmit signals. Its very presence would be the message, an unspoken warning that eyes are on us, and here duality arises. Could such a probe be protective rather than hostile? One interpretation frames it as a guardian, quietly monitoring younger civilizations to ensure they do not stumble into danger. In this light, its silence is not threatening but merciful, a way to avoid drawing attention from predators further away. Mars, barren yet close, would be a safer staging point for observation. The planet becomes a shield, an experimental outpost from which humanity can be watched without exposing Earth directly. Yet the darker interpretation refuses to fade. In a cosmic wilderness of fear, the safest strategy is preemptive elimination. Civilizations that reveal themselves may risk annihilation. If 3I Atlas is not a scout but a weapon probe, its presence near Mars could signal preparation, not protection. The energy patterns that defy cometary sublimation could serve as propulsion or weapon systems, dormant for now, awaiting some hidden trigger. The crystalline fragments drifting from its body could be byproducts of advanced materials, engineered not for natural outgassing, but for structural endurance under interstellar travel. Think of the silence again. Natural comets emit radio noise, static signatures from ionized particles streaming through solar winds. Artificial craft, too, should leave traces, communication pings, control signals. But 3I Atlas yields nothing, as though its design anticipates our monitoring. This radio quiet aligns eerily well with the dark forest mindset. If you wish to survive, you do not announce yourself. You hide, you mimic the natural, you pass unnoticed. The unsettling possibility is that this mimicry is not accidental. By imitating a comet, by embedding itself within the ordinary, 3I Atlas could travel without suspicion until it reached its destination. Mars, then, might not be chosen for its emptiness, but for its proximity, a testing ground, or a staging platform within range of Earth. In such a view, humanity's role is not that of casual observer but potential target. But pause for a moment. Perhaps this is fear coloring interpretation. Skeptics argue that 3I Atlas fits no perfect narrative. Its anomalies stretch our models, yes, but nature has surprised us before. Stars produce exotic isotopes, comets fracture into unexpected patterns. Gravitational forces shape orbits in ways our equations fail to predict. To leap from anomaly to weapon is a leap built on unease. And yet, the timing, the precision, the eerie silence, these patterns echo too closely the very logic of the dark forest to ignore. reflect on the implications if this is true. The faint tremors beneath Mars, the shifts in its atmosphere, the strange dust scattering like engineered residual could be preliminary tests, soft probes of planetary resilience. In the forest analogy, this is the snapping of twigs under cautious feet, movements concealed beneath shadows until the hunter strikes. If Mars is the chosen ground, then Earth may be next on the trail. The scenario does not end with destruction alone. Another perspective imagines 3I Atlas as an enforcer of order, part of a wider system that ensures no civilization grows reckless. In this frame, it could be a deterrent, silent reminder that expansion must be tempered with caution. Like a hunter leaving footprints for others to find, its approach warns us. Tread carefully, for others are watching. Mars might be less a target than a demonstration, a stage for teaching. Still, the ambiguity gnaws. A guardian or a predator, protection or threat. We cannot yet decide, and perhaps that is the most unsettling truth of all. The dark forest theory thrives on uncertainty, on the absence of trust. If 3I Atlas embodies this theory, then humanity's choices grow narrower. To send signals, to announce ourselves, could invite discovery. To remain silent leaves us blind. Either path risks consequences we cannot predict. As the comet draws closer, its quiet presence sparks both awe and dread. If it is merely ice and dust, it will pass into history as another cosmic wonder, extraordinary yet natural. But if it is not, if it is the embodiment of the dark forest, then we may be facing a moment unlike any other in human history. And so we end this scenario, as we began it, with silence. The silence of the cosmos, the silence of 3I Atlas, the silence of questions we cannot yet answer. In the dark forest above, something stirs, and as Mars glows faintly in the night sky, the question whispers, is this silence protection, or the quiet before the strike? For centuries, chemistry has been our quiet key to understanding the stars. By studying the ratios of isotopes, the subtle variations of elements shaped in the hearts of dying suns, we decode the history of galaxies. These ratios are fingerprints of creation, left behind by the explosive furnaces of supernova or the slow fusion within stellar cores. They do not lie, and they rarely surprise. But 3I Atlas refuses to play by these cosmic rules. When scientists turned their instruments toward its spectral fingerprints, they expected to find the usual signatures: oxygen in familiar proportions, carbon in predictable balances, hydrogen ratios consistent with frozen wanderers drifting from distant nurseries. Instead, they found something startling. The isotopic distribution of 3I Atlas doesn't fit. The ratios are skewed in ways that stellar models cannot easily explain. It is as though the object carries chemical recipes that nature should not have written. Some isotopes appear concentrated far beyond natural abundance. Others, curiously scarce, leave gaps that theories cannot yet bridge. To chemists and astrophysicists alike, it feels less like a cosmic accident and more like the careful balance of a laboratory. This is where suspicion begins to rise. In industry on Earth, we refine isotopes to achieve precision uranium separated for nuclear energy, medical isotopes produced for scanning and treatment, materials purified for delicate engineering. Nature rarely produces such clean separations on its own. The fingerprint of 3I Atlas resembles, disturbingly, the byproducts of intentional refinement, if natural. The anomaly demands that we rethink our understanding of stellar formation environments. Perhaps 3I Atlas was born in a place unlike any we have studied, a corner of the galaxy where fusion, pressure, and elemental cycles behave in ways unknown to us. A place where matter is forged in extremes beyond the boundaries of our models. Such a discovery would be extraordinary, forcing astronomers to redraw the map of stellar processes. It would mean the cosmos holds factories of matter more exotic than we ever dared. Imagine, but the alternative presses heavier on the imagination. If not natural, then what we see in these isotope ratios could be deliberate. A sign of post-formation processing, where matter has been sifted, sorted, and reconstructed for purposes unknown. Think of it like this. In nature, you find, or in the ground, scattered with impurities. In technology, you smelt and refine it, crafting pure metals for machines, tools, or reactors. What if 3I Atlas is not simply debris from an ancient star, but a vessel carrying materials processed by intelligence? Consider the possibilities. Concentrated isotopes could serve as fuel, efficient and long-lasting, for journeys across interstellar distances. Scarce isotopes might have been stripped away, harvested for use elsewhere. Or perhaps the patterns are not about fuel at all, but about stability. Engineered structures demand balance at the atomic level, uniformity that prevents decay, durability that withstands the violence of deep space travel. The isotope map of 3I Atlas could be less the fingerprint of birth and more the blueprint of design. Skeptics, of course, push back. They argue that anomalies in observation are common, that calibration errors or atmospheric interference could explain skewed data. But the consistency across multiple instruments and independent teams weakens that defense. Different telescopes in different parts of the world, even orbiting above Earth, have detected the same irregularities. This is not a single glitch, it is a repeating pattern, persistent and undeniable. So the debate circles around one haunting question: if refined, then by whom? Who or what would take the time to engineer matter at such a granular level, then cast it into the void aboard a body like 3I Atlas? Was it meant to travel unseen, blending into the stream of comets and asteroids that sweep across the galaxy? Or was it designed to be found, its anomalies a quiet signature waiting for another civilization to notice? The thought carries weight when paired with the object's trajectory near Mars. If these isotopes are the residue of purpose, then their presence near a world that once carried rivers, lakes, and seas gains new meaning. Could the chemistry of 3I Atlas be tuned for planetary interaction, calibrated to merge with Mars' thin atmosphere or soil? Could its isotope map be less about survival in space and more about transformation upon arrival? And here the dual framing becomes sharp. On one side lies the possibility of cosmic rarity, natural wanderer, exotic but unintentional, born from stellar chaos we do not yet understand. On the other side lies the chilling possibility of engineering, a sign of agency, of thought, of intent, woven into the very atoms of a celestial visitor that the silence of 3I Atlas offers no answer. It drifts, indifferent, while instruments strain to decode its secrets. The numbers are clear, the ratios defy the known. The meaning, however, remains hidden. Scientists tread carefully, reluctant to leap toward extraordinary claims, yet unable to deny the extraordinary data before them. Think about this for a moment. To find one anomaly, strange rotation, an odd orbites, unsettling but survivable. To find a second dim mismatch in energy, a whisper in magnetism raises questions. But to peer at the atomic level and see the mark of what looks like deliberate shaping that touches something deeper. It is no longer about astronomy or physics. It is about intent, about agency, about a universe that may not be as empty of will as we once thought. And so we close this section where we began with isotopes, those quiet markers of cosmic history. Only now, they no longer read as a simple record of stellar processes. They feel like handwriting, like a script written in matter itself. Whose hand, natural or artificial, inscribed it? That is the question. And as we step forward, the mystery deepens. For if isotopes can carry such whispers, what else might 3I Atlas reveal when examined more closely? If refined, then by whom? Beneath the rusty surface of Mars lies silence, or at least that is what we believed for decades. Our orbiters, landers, and rovers have scanned its plains and cliffs, recording canyons the size of continents and dunes that shift with the whisper of thin winds. Yet when scientists began probing deeper with advanced radar, bouncing signals through the Martian crust, they found something unexpected: echoes, patterns that refused to scatter like ordinary stone, signals returning in shapes that hinted at structure. Too many geologists. These echoes suggest nothing more than natural layering. Lava flows cooled into slabs, sediments stacked by ancient floods, caverns collapsed and reformed. Nature leaves behind its own architecture, and Mars, with its violent history of volcanism and water, could easily produce echoes that mimic walls, vaults, and buried chambers. From this perspective, the radar signals are illusions, patterns shaped by geology, nothing more. But others hesitate. They note the sharpness of the reflections, the angles too precise for randomness, the repeated patterns echoing across different regions. These do not resemble the chaos of shattered rock. They resemble design. And in the silence of Martian deserts, that possibility unsettles even the most disciplined minds. If natural, then Mars is a puzzle of geology we have only begun to read. But if artificial, if those echoes truly mark buried structures, then our understanding of the red planet is incomplete in ways that reach far beyond science. Such structures would imply presence. They would suggest that Mars was once host to something more than wind and stone. Consider the unsettling timing. As 3I Atlas drifts near Mars, radar echoes grow louder in our data. Some dismiss this as coincidence, the result of better instruments and more frequent scans. But others wonder, are we being nudged? Is the trajectory of 3I Atlas linked not only to Mars' orbit, but to what lies beneath its crust? The echoes raise questions that arbiters alone cannot answer. And here lies the duality. On one side, the rational voice of geology insists on caution. Rocks fracture, lava hardens, sediment deceives. On the other side, the whisper of mystery insists that patterns are too deliberate, too sharp, too aligned with geometry to ignore. In quiet moments, even seasoned researchers admit they cannot shake the feeling that Mars is keeping secrets. Imagine, for a moment, the implications. If those echoes mark hollow chambers, what rests within them? Fossils of long extinct life, relics of an ancient Martian civilization, or perhaps installations far older, left behind by travelers who shaped worlds not their own. To think of structures beneath the crust is to accept that Mars may not just be a relic of cosmic history, it may be a monument. But before conclusions, a softer reflection arises. Perhaps what we truly hear in these echoes is not evidence of walls or halls, but our own longing. Our instruments detect patterns, and our minds, desperate for meaning, complete the image into something more. Structures or illusions of hope. The question lingers, soft and heavy, as we prepare to move forward. Because whether carved by geology or design, the echoes beneath Mars remind us of one truth: the surface of a world is never the whole story. What lies beneath may alter everything we thought we knew. And as 3I Atlas hovers near, the resonance grows, the mystery deepens, and so does the silence. When we look at 3I Atlas, streaking through the darkness with its strange energy patterns and inexplicable discipline, one question rises quietly above all others. What if it is not here for us at all? Imagine for a moment that this object is not a probe sent to observe, nor a weapon designed to test, but something far more vulnerable. What if it is a vessel refuge adrift in the void, carrying within it the remnants of a civilization that could no longer remain in the place it once called home? From a natural perspective, this is only speculation dressed in wonder. Comets wander our galaxy endlessly, pushed from distant cradles by the violence of gravity and time. Mars' proximity to 3I Atlas may simply be coincidence, an accident of celestial mechanics. A natural rock, cold and indifferent, has no reason to seek shelter. It passes by planets not as sanctuary but as waypoints along a blind journey through eternity. And yet, the anomalies tug against that explanation. The stable rotation, the inexplicable isotopic ratios, the thermal signatures that whisper of internal regulation, these do not speak of chaos, but of intention. If 3I Atlas is more than stone and ice, then perhaps it is something else entirely, a wandering ark, carrying survivors across a sea of stars. In this frame, Mars becomes not a test site, but a haven. Its deserts are harsh, but its proximity to Earth, its water locked in ice, and its thin but manageable atmosphere make it a potential outpost. A civilization fleeing destruction, be it war, collapse, or the death of its star, might see Mars as a place to hide, to pause, to rebuild. The theory is haunting, yet oddly comforting. Maybe 3I Atlas does not come to conquer, but to survive. But what if survival for one means danger for another? A vessel seeking refuge does not arrive empty. It arrives with needs, resources to extract, shelter to claim, perhaps even a willingness to displace others if cornered. And from that angle, the narrative changes. A refugee vessel becomes an invader by necessity. Mars may be a sanctuary, but it could also be a staging ground. If survival demands control, then Earth may soon feel the echo of that choice. This duality leaves us suspended. On one hand, we see the image of a weary traveler drifting across the galaxy in search of nothing more than peace. On the other, we cannot ignore the possibility of strategic arrival, cloaked in silence, waiting for the moment to reveal intentions, refuge, or invasion. Both possibilities carry weight. Think about that for a moment. When humans flee catastrophe, we search for safety. But safety often comes at a cost. New lands must be reshaped, sometimes taken. If a civilization has crossed interstellar space, they would understand these trade-offs even more deeply than we do. And perhaps to them, Mars is not a mystery, but a destination chosen long ago. In the quiet of speculation, another question emerges, softer but sharper. If 3I Atlas is indeed a vessel, who or what's inside? Survivors in suspended animation, artificial minds guarding fragments of memory, or perhaps nothing but the remains of a journey too long to endure, a grave drifting through the stars, mistaken for an invader. The mystery does not release us easily. Every anomaly can be seen through two lenses: chaos or purpose, accident or design, stone or vessel. And each new observation seems to draw us closer to an uncomfortable realization that Mars may not be empty for much longer. And here, as the theory rests between comfort and unease, we leave the question unresolved. Is 3I Atlas seeking shelter from the storm, or bringing the storm with it? This is not an ending. This is only a deeper beginning. The universe thrives on coincidence, or so we often believe. Stars are born, planets collide, comets drift, and galaxies weave through one another in a cosmic ballet too vast for human comprehension. Yet, every once in a while, an alignment occurs, so exact, so mathematically improbable, that the word coincidence begins to feel thin, stretched to its breaking point. 3I Atlas has become one of those alignments. Its arrival does not merely fit within an ordinary orbital cycle. It coincides with windows of opportunity so narrow, with trajectories so precise, that astronomers whisper among themselves about probabilities that collapse into near impossibility. To put it simply, the odds are not kind to randomness. When we run the math, the improbability sharpens. Imagine a dart thrown across the galaxy, landing squarely on the bullseye of a spinning wheel. Just as the wheel's shadow aligns with a second, smaller target. This is how the approach of 3I Atlas to Mars feels: an accident so statistically rare it echoes, less like nature and more like intent. The calculations show that such synchrony should occur once in many millions of years. Yet here it is, unfolding in our lifetime. And here arises the duality. On one hand, mathematics itself warns us to be cautious of imagination. Probability is not destiny. Rare events do occur. Comets do not ask permission before tracing paths that happen to align with our calendars or expectations. The rational view insists this is still chance, however staggering. But chance has its limits. At what point does improbability demand a second look? Scientists who favor caution remind us of Earth's own history of improbable alignments. The impact that birthed our moon, the precise conditions that allowed life to bloom, even the orbital stability of our solar system, balanced across eons, may be seen as improbability stacked upon improbability. We are, after all, the product of chance. By that reasoning, 3I Atlas is simply one more roll of cosmic dice. Strange, but still within the realm of nature, and yet the whispers of intent remain. Its timing coincides not only with Mars' orbit, but with Earth's period of maximum visibility. With observational windows designed by fate to give us front row seats, it arrives at the very moment our instruments are sensitive enough to notice its irregularities. Too early, and it would have slipped past unnoticed. Too late, and our technology might have been distracted elsewhere. The alignment is not merely physical, it is historical. We are here, ready, waiting. And so is it. Think of it this way. If you hear footsteps in the forest, at the exact moment you pause to listen, is it truly chance, or is it presence? The synchrony between our readiness and its arrival feels less like coincidence and more like choreography, a pattern woven across time. The poetic truth is hard to escape. Coincidence breaks under the weight of mathematics. Numbers do not lie, and in their silence they tell us that chance alone seems insufficient to explain what is happening. Still, we cannot prove intent. We can only stand in the tension held between the rational and the mysterious. Could 3I Atlas be following a calculated schedule? One designed to intersect with civilizations just as they reach a certain threshold of awareness? Or are we simply flattering ourselves, imagining that the cosmos bends toward our small timeline, when in truth it is only our minds that connect dots in the dark? This is where mystery becomes most powerful, not in giving answers, but in sharpening the questions. If the timing is deliberate, then someone, somewhere, planned it. If it is not, then we are staring at an accident so vast it feels indistinguishable from purpose. Either way, we are reminded of our fragile position in the universe, waiting, watching, wondering, and so the synchrony holds, unbroken, taunting us with its perfection. Too improbable to ignore, too unprovable to confirm. It is a riddle written not in words, but in numbers, drifting silently between Mars and the stars, whispered into the dark. If this was not chance, then what kind of intelligence bends probability to its will? The first responses to something that might change our understanding of the heavens are quietly human. They begin not with headlines, but with conversations in dim control rooms, with eyes on monitors and mugs of cooling coffee beside sticky notes of orbital elements. As 3I Atlas pushed deeper into the inner system, and the pattern of anomalies around Mars grew harder to ignore, the global scientific enterprise moved with that same low, deliberate rhythm: measure, verify, confer. NASA shifted priorities for a few of its high-value instruments. The European agencies discussed retasking an orbiter's spectrograph for a single pass. Private aerospace firms offered observing time on commercial platforms. What we saw on the surface was cooperation, but beneath it ran a tension between speed and care. Science runs on a ritual of confirmation. Raw counts arrive from telescopes. Calibration teams peel away instrument signatures. Independent groups attempt to reproduce results with different hardware and different analysis pipelines. That choreography exists for good reason. Extraordinary claims require extraordinary verification. Yet time is an uncooperative partner when the object understudy is moving fast and the window of opportunity narrows each day. Committees that normally take months to converge found themselves condensing agendas into nights. Working groups that would publish incremental technical notes instead drafted situation reports addressed to ministers and mission directors. The need for careful analysis collided with the urgency of a transient encounter, and every organization felt the strain. Political friction followed scientific urgency. Space agencies operate within national budgets, diplomatic mandates, and legal frameworks. Reallocating mission time means postponing other research and answering uncomfortable questions in parliaments and oversight boards. Private companies, now major players, with their own telescopes and data streams, added capability but also complexity. Commercial platforms can task faster, but they answer to shareholders and contracts, not to public science norms. Questions that would once have been purely technical, who owns the raw data, which analyses are released to the public, and when, became political. Nations and corporations negotiated data-sharing arrangements in carefully worded memoranda, trying to balance transparency with operational and commercial concerns. Defense establishments watched closely. The line between a novel natural phenomenon and a strategic risk is thin in policy rooms. Radar networks, signals intelligence, and classification systems developed for national security offered data that civilian scientists lacked: high-cadence tracking, unusual radar signatures, and wide-area monitoring that could reveal perturbations. But involving defense assets brings immediate sensitivity. Once a radar track is labeled as a matter of national security, access narrows. Some governments argued for compartmentalization of particularly ambiguous data, citing prudence and the risk of misinterpretation. Others pushed for the widest possible scientific collaboration. Those debates were rarely public, but their consequences were not. They shaped what the broader world would learn and when. Legal frameworks creaked under these novel circumstances. The Outer Space Treaty gives us broad principles: peaceful use, free access, non-appropriation, but it was not written to address an apparent interstellar visitor influencing a planet's environment. Who has authority if an object transits multiple jurisdictions? What obligations exist if there is reason to believe a visitor may be altering a planetary surface or atmosphere? Lawyers and policy analysts in international working groups hurried to reinterpret existing norms and draft contingency protocols. But law evolves slowly by design. In its absence, institutions weighed ethics as much as jurisprudence. Ethics proved to be a stubborn partner. Scientists prize openness. Data shared widely accelerates understanding and builds collective confidence. Yet another values stewardship counsels caution where premature disclosure could cause harm. Imagine a headline that declares an impending planetary transformation before analyses are convergent. Markets might wobble. Supply chains could react. Conspiracy industries would race to monetize fear. Some argued that withholding partial findings was paternalistic. Others argued that publishing unvetted anomalies was irresponsible. The result was an uneasy compromise in many quarters. Carefully worded public statements that acknowledged unusual findings while emphasizing uncertainty and ongoing analysis. Those statements were intended to soothe, but the gaps between scientific cadence and public appetite left space for rumor. Communication became its own field of operation. Social media amplified every amateur image and every speculative blog. High-quality observations from citizen scientists streamed into public forums faster than professional teams could vet them. News cycles demanded instant, digestible summaries, while the work required to produce accurate, contextual information takes time. Agencies tried to thread the needle, regular briefings that explained methods and uncertainties, educational pieces that reminded the public how scientific verification works, and promises of updates when convergent evidence appeared. But the human impulse for narrative filled any silence, and with it came speculation, some thoughtful, some wildly fanciful, which in turn complicated official messaging. Practical constraints, limited action. Spacecraft are not infinitely flexible. Mars orbiters have finite fuel, limited pointing agility, and mission timelines optimized for planetary science. Reprogramming an orbiter to follow a transient interstellar visitor might jeopardize its primary mission. Building and launching a dedicated interceptor is a scale of effort decision that cannot be taken lightly. Design, testing, and launch windows mean months or years, and the visitor's passage might be over long before any new craft arrives. These engineering realities forced planners toward creative alternatives, maximizing remote sensing from existing assets, coordinating global telescope campaigns, and capitalizing on opportunistic passes by instruments already in space. In response, informal coalitions formed. Cross-agency working groups shared calibrated datasets under data use agreements designed to protect both scientific integrity and national interests. Commercial providers contributed observation time in exchange for co-authorship and technical collaboration. Academic centers hosted rapid analysis workshops, drawing on planetary scientists, spectroscopists, orbital dynamicists, and ethicists. These coalitions did not erase differences, but they created channels that reduced duplication of effort and increased the pace of analysis. Even as institutions maneuvered, the human dimension remained central. Scientists described a mix of exhilaration and anxiety. Exhilaration at a potential window into processes beyond our experience. Anxiety about the implications of being unprepared for answers that could be transformative. Policymakers spoke of trade-offs that lost little in translation. Do you prioritize immediate disclosure at the risk of chaos? Or do you withhold information to buy time for analysis at the risk of eroding public trust? Those choices were not theoretical exercises. They were moral decisions with global consequences. And so the central question narrowed, simple and terrible in its clarity. Do we reveal, conceal the truth? The answer is not a single policy, but a crossroads. Reveal and risk panic, misinterpretation, and the exploitation of uncertainty. Conceal and risk loss of trust, the spread of disinformation, and the missed benefits of collective analysis. Either choice shapes how generations will look back on this episode, as a triumph of collective curiosity or as a failure of shared stewardship. In quiet rooms, leaders rehearsed statements. In labs, scientists pushed instruments another hour. In the public square, speculation grew like a low tide. The tension itself became part of the story, and human anomaly, mirroring the cosmic one that asked as much about our institutions and ethics as it did about the visitor drifting through space. The next steps would test not just our telescopes and models, but our capacity to decide together how to live with a universe that may no longer be indifferent to us. For weeks, observations circled like shadows energy that defied known physics, quakes that multiplied in eerie synchrony, whispers of magnetic fluctuations, atmospheric signatures that seemed too precise, echoes beneath the crust, and alignments too perfect to ignore. Each anomaly on its own could be debated, explained, dismissed as error or chance. Yet together they form a pattern that grows harder to look away from. And patterns have power. They whisper of intent where randomness should reign. It is within this growing convergence that the Mars theory takes shape. A theory whispered first inside meetings, then debated in late-night calls across agencies, and now moving quietly into public speculation. Mars may not be a bystander in this story. It may be the stage. Consider the evidence from the simplest perspective. Mars has long been the planet we imagine reshaping an atmosphere thin, but not absent. Water frozen, but present. Gravity weaker, but workable. Days almost mirroring Earth's rhythm. For decades, scientists and dreamers have described Mars as the world most ready for transformation, a candidate for seeding or terraforming. Now, as 3I Atlas drifts near, the anomalies seem to converge on that very idea. As if echoing our own ambitions back to us, some scientists frame it in natural terms. A comet carrying unusual chemistry could deposit volatiles onto Mars, enriching its atmosphere and altering its climate in ways that mimic seeding. Cosmic accidents have changed worlds before the asteroid that delivered water to early Earth, or the impacts that may have triggered Martian floods billions of years ago. By this lens, 3I Atlas may simply be a wandering catalyst. Its materials and trajectory fated to brush against Mars at the right moment, shaping it by chance. Yet the other frame refuses to fade. The precision of its path, the timing of its approach, the anomalies that suggest active regulation, all these details point to something less accidental. If deliberate, then Mars may be a chosen target, a planetary laboratory in progress. Terraforming, seeding, testing, the words carry weight, unsettling yet strangely logical. The idea that another intelligence could use Mars as a canvas for planetary engineering challenges not only science, but imagination itself. The question deepens when we consider motive. If Mars is being modified, why? One possibility is preparation for colonization, for refuge, or for experimentation that requires a world without a shield of magnetic fields or a thick blanket of atmosphere. Another possibility is warning, a demonstration of capability, visible to us, showing what could be done on Earth if intent shifted from subtlety to action. And a quieter, more haunting thought lingers. Perhaps Mars has already been modified before, and what we are seeing now is only the continuation of a cycle older than humanity. In the calm light of speculation, the line between natural accident and deliberate design grows thin. Perhaps Mars is breathing differently because of dust and gas delivered by coincidence. Perhaps the echoes beneath its crust are simply fractured stone. Perhaps the synchrony is a mathematical illusion. And yet, when these possibilities gather in one place, at one time, they sketch a narrative that feels less like chance and more like a story being written deliberately, chapter by chapter, on the surface of our neighboring world. Think about what that means. If true, then Mars is no longer just a dusty red sphere wandering quietly around the sun. It is a planet in transition, a world with its own future, reshaped by forces we do not fully understand, whether by accident or intention, whether by comet or craft. It may be in the midst of becoming something different from what it has been for billions of years. And here, in the soft silence of reflection, a question arises: which future awaits Mars? Will it be seeded with the chemistry of life, tested as a site of experiment, prepared as a refuge or a weapon? The possibilities expand outward like ripples on still water, each carrying consequences that reach beyond Mars itself to Earth, to the story of humanity's place in the cosmos. The theory is not proof, and the proof is not yet ours to hold. But the weight of anomalies presses against silence, and in that weight Mars stands transformed not yet in substance, but in meaning. For if Mars is the target of planetary modification, then we must ask what role we play: observers, participants, or subjects of a story still unfolding. The calm suspense lingers. Terraforming, seeding, testing. Which future awaits Mars? Mars has always been our mirror. Through its rust-colored valleys and frozen deserts, we have seen reflections of our own ambitions, our own longing for exploration, our own fragile hope that another world might hold answers to questions too heavy for Earth alone. Yet tonight, that mirror feels different. It reflects not only our curiosity, but our uncertainty, our awareness that forces beyond us may be shaping Mars into something we do not yet understand. We have walked together through a gallery of mysteries, energy signatures that defy known physics, quakes echoing in rhythm with an interstellar visitor, magnetic whispers that hint at interference, and atmospheric oddities suggesting chemistry far from random. We traced the precision of silent rotations, the improbable synchrony of arrival, the dust that glitters with crystalline defiance. We followed theories of seeding, of terraforming, of experiments whispered into the crust of a planet long thought still. And through it all, 3I Atlas has hovered, neither fully comet nor clearly machine, suspended between natural wonder and deliberate design. Perhaps these anomalies are nothing more than the tricks of a vast cosmos, coincidences piled so high they feel like intention. Or perhaps they are signals, carefully layered, left for us to interpret. The truth remains hidden, balanced on a knife's edge of possibility, as fragile as our own understanding. And so we end not with answers, but with a question. Mars may be more than a silent neighbor. It may be a laboratory, a target, a message written in dust and stone. Or it may simply be itself wild, indifferent, unchanged by our interpretations. Will we ever know the truth? Or will Mars keep her secrets forever? If this journey calmed your mind and sparked your curiosity, stay with us. Each night, the cosmos offers new mysteries, and together we can wander through them softly, slowly, without haste. If you'd like to keep dreaming with us, consider liking this video, sharing it with others who find wonder in the stars, and subscribing so you never miss the next story. Until then, let your thoughts drift, your mind rest, and your dreams carry you deeper into the quiet of the universe.